Hi, in this video I'm gonna show you guys a word problem that will require our knowledge on finding definite integrals. So we have came across several examples on applying our knowledge of integration on kinematics, right? Object that moves. Now, kinematics is not the only application of integrals, right? So, because every time when something is changing, when we have something that changes, we can always use the derivative to tell us how fast it is changing. In terms of math, that would be the slope, right? The slope is the change. Okay, so we can also apply integrals to any context that has change that involves. Okay, so I want you guys to pause this video and take a look at the question we have here. Okay, welcome back. So we're talking about bacteria, right? And the initial population is 100, right? The initial population is 100, and the rate of change over some time is this. This is the rate of change, right? And the value that I get out of this function, this R of t, is the number of bacteria per day. Okay, so now the question wants us to find the population of bacteria 20 days later. In other words, this is R of not R. R is the rate of change. So they actually want us to find the population 20 days later. So in other words, let's say this is the population after 20 days. Okay, that's what we have to find. All right, so let's do this. This R of t, that is the rate of change, right? That doesn't give us the population. That tells us how fast it is changing. Okay, so if we're given the rate of change, for example, another typical example of rate of change would be velocity, right? Velocity is the rate of change of your displacement, right? Or I can say acceleration is the rate of change of your velocity, right? We know this already, right? We knew this a long time ago. So now, if I'm given the rate of change of the population, and I need to find something that I actually have to find the population, right? The P of t is gonna be equal to the integral of my R of t. Does that make sense? Right, because my R of t is the rate of change of my population, right? So if I integrate that with respect to t, I will get my population. Okay, so let's try to do this. So my P of t is equal to the definite integral of, this is indefinite integral because I don't know where to where, right? I don't know where to where. So we are doing indefinite integral here. My R of t is e to the power of 0.273 t dt. So we are pretty comfortable with finding integrals now. So that's the answer for this will be e to the power of 0.273. And if I differentiate this, I'll get a fraction. The fraction is going to be 1 over 0.273 plus, don't forget the plus c. Now, we sort of have this P of t already, and that's good, right? There's one piece of information that we have not used, which is the initial population. Initial population means your P of 0, correct? Your P of 0. Your P of 0 is equal to 100, which is also equal to. So now let's put that in my equation. My equation of P of t, 1 over 0.273. e to the power of 0.273 and my t is 0, right? Plus my c. So 1 over 0.273, that gives me 1000 over 273. Right? And I have a 100 here. And e to the power of this whole thing becomes 0. This whole thing becomes 0. So e to the power of 0 gives me 1 plus c. So my c is equal to 100 minus 1000 over 273. Right? Okay, which is equal to 26. Let me put that in my calculator. I'll be back. That value is 26300 over 273. So that's my c, right? I've just found my c. So it is. So my p of t is now complete. This is equal to so 1 over 0.273 e to the power of 0.273 t plus the c, which we found just now, 26,300 over 273. This is 273. All right, so that's my P of t. That's my complete P of t, right? Now, they want us to find P of 20. So now we just put that in, P of 20. And we will have to use a calculator for this, but this is not bad, right? Because all we have to do is substitute the values in there. E to the power of 0.273 times 20, and then plus the fraction. 273. And you should get your final answer is going to be, so this is when you use a calculator, and your final answer should be approximately 957. All right, so after 20 days, we started with 100, but after 20 days, we will have approximately 957 bacteria. Okay, that's it. I'll see you guys in the next video. Bye.